Good afternoon. It's Tapan Bagche again, and we resume the series of lectures here on Six Sigma. The special topic that we have for this session for you is the use of Six Sigma concepts in improving the performance of supply chains. As I get into this topic, I'll be discussing things that have more to do with perhaps logistics and some with quality. And you'll see how we take an example, take a real problem, and we define it, then we measure the performance as it is, then we try to analyze it, then we look for improvement objectives, improvement possibilities, and then of course we try to control the optimum settings of the various parameters of the system. So to begin with, let me give you an idea of what a supply chain really is. A supply chain basically is, it starts with raw materials in many cases. It starts with some very basic input material, and the objective finally is to deliver products which are directly usable by consumers. That's what the goal is. A supply chain comprises many steps, many stages, whereby we transform the input into intermediate products, then perhaps parts, then perhaps transport them to a process, to a stage where it's processed, parts are assembled into a product, then finishing touches are produced, and then of course we ship it out to where the customer actually is. So the supply chain consists of acquiring materials all the way to the final delivery of the product and installation of it in the consumer's location. That's what a supply chain is. Now in doing this, of course, you got to worry about logistics, that's one thing. You also have to worry about the processing speeds, you have to worry about transportation speeds. That's something you got to worry about. You also have to worry about moving various parts to an assembly place, and this could involve, for example, going through assembly plants, then going through a port which does the transit, then doing the assembly, then of course moving out the assemblies to a place where perhaps a retail shop is, and from there customers are served. In fact, the diagram that I show here is the supply chain for a PC, the personal computer assembly business. It comprises suppliers who are international, they may be spread around the globe. Then of course we've got assembly plants which are also located at various different places, and these places may not coincide with the place where the parts are made. Then of course the assembled parts, they are moved perhaps by shipping or by truck or by some other means to places where we've got transshipment points. Here we probably sort out the orders and we try to make sure that the final destination they received whatever they have ordered, they'll be receiving those things. Then of course we move them out to retail shops, and that's a countrywide distribution network. And from there retailers pick up their material and they supply to the final consumer. This is a full supply chain for a PC supply business. There are issues obviously of transportation times, processing times, and quality checks and so on and so forth, and making sure everything to try to make sure that the customer wants whatever he wants, when he wants, in the right quantity and so on. That's like the objective, that's like the overall objective of a supply chain. This is a much more complex process than just trying to operate your single unit, your processing plant or your assembly plant or just your transportation system. This is an integrated system, and it must all function, all parts of it must function properly and in a synchronous manner. Here's a supply chain schematic for the Asian Paints Company in India, and it shows the various steps they go through to try to reach your walls in your homes or apartments. They begin of course with ingredients which are like active materials. These go into making the paint. Then they've got certain components that must be brought together. Then they've got packaging material. These are all brought together into what we call factories. These factories are places where the paint is made and the basic packaging is done. After the packaging has been done, which could be in tin containers, put in cardboard boxes, then palletized and so on and so forth, those are moved to regional distribution centers, and Asian Paints has 6 of those countrywide within the country, within the subcontinent of India. Then of course there are these regional distribution centers. They feed in turn 72 depots. These are simpler, smaller warehouses. From there, 15,000 dealers are served, 2,000 institutional buyers are served, and exports are made. And then you can see the final product. The final product is put on your walls, or by these are supplied by the dealers, and then the institutional buyers, they would be probably acquiring large quantities of paints to paint up an apartment complex, for example. Then of course you've got exports, which could be going for outside coating of for example, a vehicle, automotive vehicle, or they could be also going into the domestic market and appliances and so on and so forth. That's the export market to which the same paint reaches. You can actually see it goes through several stages. Many of these stages, these basically are processing steps. Then of course there are some storage depots and warehouses. Then of course you've got transportation systems involved, and then you've got dealers and so on. Now I should tell you one thing, that the final product gets customized right at the dealer's shop. There, what they do is they take the base paint that is made by the factory in large quantities, and those are put in containers, which are fairly large containers. Then those are put into a measured container, and there the right kind of tint is added to that base paint to match, for example, your curtain, for example, or your furniture, or your flooring, or your roofing, or whatever it is. Whatever you want to acquire, you want to achieve a color match for, the best color match for, that is done right at the dealer shop by using a special machine which does this tinting of the base material. Then of course you can take the product and you can put it on your walls. Same thing applies all the way when you reach the final customer. So this is like a big supply chain which has got many stages and many transportation units that is utilized by Asian Paints. They use a fair amount of technology here. They make sure that they have the stock control, they have sequencing done, they have scheduling done, they load and unload these different equipment, which are mixers, there are tanks, there are pumps, and so on and so forth. There are pipelines, they are required to make sure that the raw material and the various in-process material, they move to the next stage in a planned manner. Then of course when the packaging done, final packaging is done, it's packaged right, it's stacked up correctly, and it's palletized and so on and so forth. Then trucks pick them up from these distribution centers. They take them to depots. From the depots, based on the orders placed by different dealers, items would be shipped either to dealers or to institutional buyers directly, or to the export area. That's probably near a dock someplace, near a shipping dock someplace. What exactly is then supply chain management? Is the management of this total supply chain that starts with the raw material and that ends up with the final use of that final product in the hands of the final user. This total thing is called the supply chain. Like I said, it's got many stages, and there may be storage involved, there may be processing involved, there may be transfers involved, there may be quality checks involved, and so on and so forth. And every time you're making sure that the following stage gets the right feed from the preceding stage, and this continues all the way till the product reaches the final destination, which is the hands of the user. That's really what a supply chain really is. It's a network of organizations. Not a single organization probably will be vertically integrated, in that it will probably not make all the raw materials. It will probably not make all the base oil, for example, in the case of oil paint, for example. The goal really is to make sure that each stage produces value for the ultimate customer. There is the least amount of waste and there is the least amount of delay caused in doing the total process. We want to definitely supply customer needs. That's something that we'd like to be able to do with a supply chain. We should be able to manage the flow of goods one way, that is going to the customer, and customer demand is fed back to the planners, first to the shipping areas, which could be like a dealer shop, for example, or a depot. Then of course it will go back to the factory, and the factory has to do the right amount of planning, the right quantities brought at the right time and produced appropriately, so that there is the least amount of stock that is carried from period to period, because this is how you reduce your stocking cost and you try to reduce the overall cost that the customer has to pay, overall price that the customer has to pay. Then of course there is the raw material that is brought into the factory so that the actual processing can take place, and the raw material is probably acquired somewhere, and again it might move through some storage and then into the factory where the processing would be done. This is the flow of goods one way. There is a backward flow of demand information that goes this way, that comes back, starts from the customer, and it slowly trickles down all the way to the raw material supplier. Money also goes likewise from the customer to the dealer, to the person who is handling distribution, and back to the manufacturing shop, and then eventually in the hands of the suppliers, the material suppliers. That's how money flows. So you've got goods flowing one way, and you've got information flowing in the reverse direction, also money flowing in the reverse direction. That's the total operation of the supply chain. You got to make sure you manage the flow of goods and information in the best manner possible. You also have to make sure that in the process you generate some profit for yourself. This is very, very important. Unless a business or an enterprise or a processing step or an activity step is profit making, nobody would be involved in it, and therefore the supply chain would collapse. So you got to make sure that whoever is involved in this supply chain business, he makes some money, he makes some profit. You got to make some very critical decisions when you're operating a supply chain. For example, deciding on location. Where should you locate your plant, for example? Where should you locate your factory? Should it be close to the raw material supplier, or should it be close enough to the final user? Where should it be? Where should the depots be located? Perhaps there are one or two big factories that produce all the goods, but what about the distribution depots? What about the dealers? Where should they be located? This is a very, very important decision in which what you really try to decide which products to produce at what stage, how to produce, how much to produce, and how to do the distribution. Unless these things are done optimally in an overall manner, this supply chain would not be profitable. Then of course, the whole business may collapse, because if people lose money in providing this service, these products and the service and the associated service to the final customer, he's probably not going to be ready to pay for it, and the business would collapse. So supply chains have become a pretty large sort of undertaking. Something we've got to remember now is because of globalization, we are doing a lot of integration, we are doing a lot of coordination, and now goods and information, they are moving through a coordinated network, and this network adds value at each step. What we are really doing is we are adding value at each step of the business process. Whether we are acquiring raw materials, we are transforming them into the final product, whether we are providing services, or we are delivering the product in the hands of the customer, which involve the following activities: procurement of the raw material and the packaging materials, for example, and perhaps the technology. We are doing the manufacturing and assembly operations. So these are again places where we are spending money. We've got some inbound logistics to bring in the raw materials and the parts and the components. We're doing some warehousing, which could be done, for example, at the raw material stage. It could be doing at the intermediate stage or the finished product stage. We'll be doing some warehousing. Then, of course, we've got distribution, which is we've got the products now in our hand, how they would be distributed first to the depots, then to the dealers, and then to the final customer. This distribution also has to be planned in an optimal manner. Then, of course, you've got outgoing logistics, which is like shipping everything out, the finished product, to the customer, to the ultimate user. These steps: procurement, manufacturing, assembly, inbound logistics, warehousing, distribution, and outbound logistics. I should caution you, these are no more made in a silo manner. We do not try to optimize procurement by itself. We worry about the full supply chain when we make some procurement decision. Same thing we do for manufacturing also. When I decide batch sizes, for example, we try to make sure that the overall system is profitable. Not just that the manufacturing system works very well, but we end up with large inventories that stay for a long time in the warehouse, sitting in the warehouse. And also we worry about supply quantities. There also we got to do some optimization. That worries about the inbound logistics. Should we move in parts one at a time, or should we move them in batches? Should we move them in large lots? Should we be moving them in trucks, or should we courier them, or however we are going to be doing it? This inbound logistics also has to be optimally fitted into the total supply chain. Then, of course, we've got warehousing. Warehousing by itself does not really add value to anything. Yes, it does keep a few people employed, and perhaps it consumes some utilities. So the utility companies, they stay in business, for example. But warehousing by itself, if I just take some goods, I take some goods and I just put them in storage somewhere. I just leave them there. They are not producing money. They are not producing any income from anyone. In fact, the time they produce money is when the product is given to the customer and he pays some money for it. That's when he's really making money. The company is making money. The company is not making money if this just lays in the warehouse in one storage. Then it's not making money. The same thing applies to a supply chain also. Whenever you've got stagnation, that means the goods are sitting, waiting to be picked up by the next stage. This is no good for anyone. So what we got to make sure is, again, warehousing, which really involve many times very large quantities of inventories, they must turn over fast. Unless they turn over fast, the working capital is going to be tied down in fact, and that's going to raise the cost of production and eventually the price at which I can offer those products to the final user. And the business is going to have a tough time competing with other people who are more efficient, who's got more efficient supply chains, for example, operating for them, and they plan them right, they schedule them right, they operate in them correctly. They are going to be out competing us, and it's not going to be easy for us to do this. Then of course we've got distribution. Now mind you, all of this must happen with perfect quality. If you do not have quality, if you're doing all these things, it's all useless. So many times what you have to do is you've got to take a step back. You've got to make sure you also do your quality inspection, you do your quality checks all the way. And ultimately the goal of Six Sigma is to try to make sure, number one, you reduce losses. Number two, you reduce defects. Both of these have to be done. Reduce losses. Losses could be in the form of any of these resources. Time, money, material resources, any of these actually cost you money. Man hours, labor hours, machine hours. If there is wastage anywhere, this is not a Six Sigma operation. So Six Sigma does try to cut down losses by applying various methods. By applying actually the DMAC framework. This is one approach. Where we can utilize Six Sigma, the philosophy of Six Sigma. The other, of course, is quality assurance or quality control or minimizing defects. And there, of course, today we are using fancy methods such as design of experiments. That's what we are trying to do. I will show you an example in this lecture here today. And you've seen this example before, but I'm going to be explaining this a little bit more with a little more clarity. That one is about using design of experiments to try to improve the performance of the supply chain, which happened to be a real situation which was in the auto sector. I'm going to be doing that a little later in this. Let's worry a little bit about inventories, because inventories, as I just mentioned, they form part and parcel of a supply chain. Let's see how an inventory typically operates. There are a couple of things to consider when you're considering inventories. First of all, if your machine could produce one pen at a time, if a factory could produce one pen at a time, if you could economically transport one pen at a time from the factory to the ultimate user of the pen, which could be a student somewhere in some college, if you could just produce one, transport it singly, economically, and then give it to him, you're taking care of his needs. That's not much of a problem. But generally what happens whenever you've got engaged in this sort of activity, it always pays to form a lot and to do what we call batch processing. So you'd like to take similar objects. You'd like to acquire the plastics for all of them together in a lump, in a large order. You'd like to produce them all together with some customizing done so you get different shades and colors and so on. But you'd like to produce these things because they're all very similar in a batch. You'd like to make sure these things move in a batch and they also get transported in a batch. Then the per unit cost of transport also is going to be less. Then of course you take it to a depot where it is stored temporarily. Then you move it out to a dealer who displays it, and then of course the customer buys whatever he wants. So in effect what I've done is I've introduced inventories along the way. I've introduced, for example, initially I'll have some plastic inventory, I'll have probably some ink inventory and so on and so forth. Then from there I'll move into partially finished goods, which could be perhaps only caps produced, many different caps. So I'll have all these different caps produced all at once and I'll be storing them. Then I'll produce these bodies and I'll be storing them again. Then I come to the assembly place where I'll be putting them together. And that's also being done in a batch mode so that I utilize the scale effect, and I'm going to be utilizing my full capacity to make sure I produce a full batch instead of just producing one item at a time. If I do that again, I'm talking about inventories. I'm not talking about a single pen, but I'm talking about many pens being handled together. And these, of course, depending on the order system, these may be sold one at a time. They may be sold one at a time. So my inventory is going to gradually come down. But they're made in a batch. So when the batch arrives, inventory jumps up all in one shot. So my inventory was here somewhere with almost no pens with me. Then suddenly I've got the inventory. I've got all these inventories. So this is the distance. This is the height of my inventory stock. That's what I'm showing here in the picture. I receive the order and immediately my inventory goes up. And then of course, as I sell the items or if I use the items, inventory starts coming down. Now, there is a policy, there is a certain inventory operating policy that is put in effect. What we do is, generally speaking, most goods take some time to produce. If you place an order today, it will take some time for the supplier to make sure he's done the production and he supplies the stuff to you. It takes some time. This is called the lead time. In fact, it's very important for us to realize that there is almost nothing that has got instantaneous supply. There's always some lead time involved. If that is so, then I should not probably wait when my inventory runs down to the zero level and then place an order. Because where is the lead time? I mean, I've not given the supplier any kind of lead time. How is he going to be instantaneous to supply the goods to me? This happens even in the case of pens, for example, which are kept in an office. The office clerk, she keeps an eye on the, she's got a drawer there, and in that drawer she keeps all the spare pens which are to be issued to different people. And what she does is she keeps an eye on that inventory. The moment it gets down to probably perhaps 2 black pens, perhaps 2 blue pens, perhaps 2 red pens, perhaps 1 green pen, she places an order. And these orders, the quantity of the order of course has to be optimal. And how often she places the order, that depends again on the stock level and the lead time. Let's take a look at that in this picture here. Here's the reorder point, which basically says whenever inventory gets down to this reorder point, I must place the order on the supplier. So I place the order and he takes this lead time to really make sure goods arrive at my door. And of course, my inventory then jumps up to this level there. This quantity is the order quantity. This is the order quantity. This is how much I ordered. So my inventory, when it was planned in such a way that the moment my inventory would get down to almost zero, I'd receive a lot, and the lot would raise my inventory to quantity Q, which is the order quantity size. Then of course again the cycle will start again. I'll start consuming the product. It will get down to the reorder point. This is when I'll place the order, and the lead time will lapse, and at that point the order will arrive and my inventories go up. And these cycles, they repeat. They are like a sawtooth, like the saw with which you cut wood. It's just inverted. It's got that sawtooth. So this is the inventory model, the sawtooth model. This is quite common, and this you can observe. If you go to a real warehouse, you'll see the variation of the warehouse inventory in a sawtooth manner. The important points here are a couple of things. One, the reorder point, then of course the lead time, and then the order quantity. When you are ordering, it's a very important decision. You're ordering in this case, if this is the policy that you're using, the one that is shown in this diagram, you're ordering as soon as your stock level in the warehouse gets down to the level of the reorder point. That's when you're placing the order. How much you're ordering? It is actually the quantity that is called the economic order quantity. I'm going to be talking about that in just 1 minute when I get to the next slide. So when you order depends on the reorder point and your rate of consumption. How much you order depends on the economic order quantity. That is how much you order. And if you do that, if you repeat these cycles, you order whenever your stock level gets down to the level of the reorder point, you place your order, then the supplier gets in action. And by the time the lot arrives, what you ordered, that full lot arrives, it's time for inventory to rise, and inventory rises to the top level there, this quantity being the order quantity. And then of course it again starts to come down in the sawtooth manner. That's what is happening there. So this is what I'm showing here as the profile of the inventory level over time. time is this way and inventory level is this way. That's what we've done there. At any point in time, if you want to know what your quantity on hand is, just draw a horizontal line. You take the time and from there you draw a horizontal line. You'll end up with a reading on the axis, quantity axis. That is how much inventory that you have at this point in time. So I can do that for any point in time. If this pattern persists, of course I've got a pretty neat arrangement there by which I can read off the inventory. Now let's try to find out how I figure out how much to order. That's done by this little formula here. And this formula actually does a little optimization. There are two parts of it. One part is called the ordering cost. This is how much it costs you to place a single order regardless of quantity. This is like checking inventory, making sure you go to the formula, you figure out your optimum quantity and so on, and then you place the order. That will involve some paperwork. Then you transmit the order to the supplier. This total activity costs some time. This is not, of course, something that's zero cost. It's an operation that is, if I write it here, is the operating cost. It's actually the ordering cost. Ordering cost is independent of the quantity ordered. Ordering cost is independent of the quantity ordered. Now this is something that is one kind of cost. The other cost that I've got involved in inventory management is called inventory cost or stocking cost. So ordering cost would involve the paperwork that is involved in placing a single order regardless of the quantity. Stocking cost, of course, is the cost of holding the material in storage at your site, at your location. What kind of cost these could be? It could be, for example, material handling, moving the inventory. It could be the floor area that it occupies, the inventory occupies. It could be the air conditioning that is going on. It could be the insurance that you've got for the quantity that you've got on the floor. Generally speaking, this stocking cost depends on quantity. So there is something that depends on quantity, and this depends on quantity Q. Q is the amount of inventory that you're holding at any point in time. And generally speaking, ordering cost is ordering cost per order, which in our case is going to be, we're going to be ordering a certain quantity and there is going to be an ordering cost, and I'm going to be denoting this guy by S. So S is going to be my ordering cost. S is my ordering cost per order. And Q is the quantity that I have in inventory, and with this I have a cost involved that is called the holding cost. It will be H, and this is generally translated into per unit time, per unit time. Now, if you look at the total cost of operating my inventory, it will comprise some ordering cost and some storage cost. So what I have to do is I have to look at the total cost. I have to look at the total cost. And this total cost, as the equation is shown on the slide here, this depends on H is the holding cost multiplied by Q is your inventory, Q is your order quantity divided by 2. Because of the sawtooth pattern, at any point in time, if you have ordered quantity Q at the beginning of the order cycle, at the end of the order cycle you've got Q has got reduced to 0. So the average inventory that is going to be there during the inventory cycle is going to be Q divided by 2. Because Q here and 0 there. So Q plus 0 divided by 2, that's Q by 2 all the way. That's your average inventory throughout. So you should be paying your holding cost, then is going to be Q divided by 2 multiplied by H. That's going to be your holding cost component. Now let's say your demand per unit time is D and your order quantity is Q. Then how many times will you be ordering per unit time? It's D divided by Q. That many times you'll be ordering. and each time you order, it costs you S units of money. So therefore, S times D by Q, this is the quantity that is the ordering cost component of total cost. So I've got two components here. I've got the ordering cost component and I've got the stocking component or the holding cost component. This total cost is now a function of the unknown decision variable, which is Q, quantity to be ordered. It's not very difficult to show that the total cost reaches a minimum, and that's this line here, that's this dotted line here. That's this dotted line here. This is the total cost time. Notice here, it's got a minimum. It's got a minimum. And this is the quantity of, this is the order size. If your order size is this, the total cost of operating the inventory again and again over a number of different cycles is going to be minimum. So this quantity Q is then called the optimum order quantity or the economic order quantity. This is called EOQ. EOQ is the economic order quantity. Now, one of the big challenges in supply chain management is that each stage of production or transformation, it ends up finding its own EOQ, because it is subjected to one kind of demand, is subjected to its own holding cost, is subjected to its own ordering cost, and so on. So they each end up determining different EOQs. And there's a way to show that this kind of fluctuation gets more and more amplified. In fact, this effect is called the bullwhip effect within a supply chain. So the dealer or the final user may have small fluctuations in demand. By the time it reaches the factory, demands have got somewhat blown up. And when it reaches the supplier, there the variations in ordering cost in the supply quantities, those have wide variations. This is called the bullwhip effect. It's like the whip with which we, it's like that bullwhip with which we whip a bull. And you notice there can be a small shaking at one end of the hip or one end of the whip there, but the far end kind of goes with a big yo-yo. That's like a big variation there. So a small fluctuation at one end causes a very large fluctuation at the other end. This is not something that is desirable for inventories. This can be reduced, this can be almost minimized if you've got information sharing. That is, if your supplier finds out what your customer requires, because then your supplier is not going to panic based on the order placed just by his immediate customer. His customer is going to be the first stage of your processing. And that guy, again, if he's aware of what the final customer is using, his inventory level fluctuations are also going to be smaller and so on and so forth. So that is there. So this way I can reduce this huge fluctuation that is there. This is a big challenge. This actually requires one or couple of things. One of which is, do not break down the total decision into silos. And don't let these guys sub-optimize their different stages. Don't let them do that. Try to work out the overall cost model. And then try to work out how these different stages must be operated in an integrated manner so that you've got total overall reduction in the overall cost of delivery, starting from the raw material all the way to the finished good. This is something we've got to be able to do. Unless we do that, the supply chain is going to have a lot of inefficiency throughout, and someone is going to pay for it. Eventually, it's going to be the customer. And if the customer has to pay a high price, he probably is going to go somewhere else. So it's in your interest to make sure your supply chain costs stay at the very minimum level possible to sustain your business. One key challenge in supply chain management is going to be, of course, to make sure this full network operates optimally. Couple of problems are there. Poor quality of supplies are there sometimes. Sometimes logistics is not quite in your control. Sometimes lead times fluctuate. Sometimes machines break down. Sometimes, of course, we are not really able to manage everything right, and the reason is we then end up putting buffers in between, and we try to decouple the different stages of supply chain. We try to decouple them by putting inventories in between. These become buffers. They try to absorb some of the fluctuations, and they do not let the fluctuations downstream, get transmitted upstream. They try to avoid that. But you then require these buffers. You require these buffers, and of course, nothing is free. Like we just saw, no matter what kind of supply chain you're looking at. These are some typical businesses in the country. For automotive, we've got the telco company, we've got Mahindras, Marutis, General Motors and so on. They are engaged in automotive sector there. They get a lot of their parts made by different people, some made even overseas, and they assemble them together. Aerospace industries, ADA, HAL and so on. Chemicals, we got a lot of suppliers, a lot of final suppliers. For clothing, apparels, we've got various suppliers, various people in business. Food, we've got Cadbury, Parle, Amul products and so on and so forth. Consumer products, we've got many of them. Forest products, construction activities, those are managed by the likes of L&T, for example. Pharmaceutical, we've got Ranbaxy, we've got Glaxo and so on. Electromechanical parts, we've got Kirloskar, L&T, and these different people, they produce these final parts which are either sent to industrial customers or they are sent to consumers. Tooling, there are companies that are engaged in that kind of business, and of course, PCs and computers, there are a large number of companies involved there. We are talking about finished products at one end, and each of these products must at some point start with raw materials. So around the country, there are many different locations where raw materials are available. There are many places where partial processing is done, and of course, markets are spread all around. Markets are spread out. Most of the metros, and now of course the rural market is also growing. So supply chains have become more and more complex, and they are spanning pretty well coast to coast the full country, all the way from Kashmir to Kanyakumari, and from the east in Gujarat, Rajasthan, all the way to Assam and so on and so forth. We got the full subcontinent covered by our supply chains. Many of these have buffers. They have buffers in the form of local inventory. They have buffers in the form of stock at the retailer. They have buffers in the form of, for example, where the depots are. They have buffers in the form of warehouses. They also have buffers inside factories, and many times part suppliers, they maintain buffers, and any of these buffers, they cost you money. And in fact, what we are looking at now is we got to make sure that the supplies take place smoothly. One of the hindrances to these supplies is going to be breakdown of machinery, or a failure in logistics, or some quality problems. And these may interrupt processing at a particular stage. Now that means that the downstream process steps, they have to stop, they have to become inactive. And to try to avoid that, what we do is we create these buffers and we start drawing from these buffers. But anytime you are adding a buffer, you are adding cost. The cure to this is going to be to go to perfect quality, which is like there should be no breakdown, there should be perfect quality should be supplied to each feeding stage and so on and so forth. This is really going to be the way you would be able to remove the buffers altogether. Let's take a look at some of these things. In the supply chain, of course, we've got both the suppliers and a customer. That's what we have. And it's very important for us to be customer focused. We've got to make sure the corporate vision is that way. And one of those things really requires you to have the TQM orientation. And like I had said to you earlier in one of the earlier lectures, TQM requires top management to be involved directly in the delivery of customer satisfaction. There should be strong customer orientation. That's also part and parcel of TQM. Everyone should be involved. That's like company-wide participation for TQM to succeed. Then you've got systematic problem-solving method. That is also there. And the theme should be continuous improvement. If you're doing these things with your 7 tools and so on, you're approaching perfect quality. You're approaching that. Of course, you need some fancy methods also. For example, you need design of experts. So TQM will set up your mindset. TQM is going to get top management involved. TQM is going to give you strong customer orientation and so on, and good problem solving methods at hand to be used not only upstairs but also right at the shop level. This is going to give you ultimately competitive advantage with the help of which you can raise productivity, reduce inventory. This is what we are after. This is what a supply chain manager is after. Reduce cycle times, boosting customer satisfaction, market share and profits. Of course, these would be the advantages. If you look at the full chain, the supply chain can also be looked at as a quality chain. You've got a number of suppliers and customers. Yes, the external customer is out there, right at the end there, and you've got the external supplier here. So the external customer is there, the external supplier is there. In between are all the intermediate processing steps. If these processing steps work perfectly, you've got no problem at all. But suppose they have breakdowns, they have quality problems and so on, then each stage is going to build a bit of buffer before it, and perhaps there may be some buffer after it also. And you'll end up with a lot of unwanted extra inventory in the full system there. That's going to cost you money in terms of working capital. That's going to cost you business also perhaps. So this is something we'd try to minimize, would like to minimize. What are some of the steps? What are some of the tools? To try to keep a process in control, that means a process at high process capability level, you should use process control charts. So that is like one big use of SPC. And you see a control chart here. This is the X bar control chart, which is used to make sure the process stays on target, as close to the target as possible. Then of course you also want to make sure that precision is there in the process, and therefore you'd like to use the range chart, and that's also part and parcel of how to operate a properly functioning supply chain. Make sure you've got control charts operating at your plants. Then of course let's take a look at again the role of TQM in supply chain. Wherever you've got a quality problem, costs are going to add on. Costs are going to rise and customer satisfaction is going to go down. And this would also be true for a supply chain. It's very important for us to realize that it's going to be important for you to keep your supply chain in order. And for that, your quality has to be in order. Let me give you an example. I'll give you one example here. In 1995, the Chrysler company, it looked at the quality of its suppliers. And what it found was that the defect levels of these suppliers, many of them range between 300 to 400 parts per million. That's a very high level of defectives coming into the plant. And that means this company, Chrysler, could not go into JIT directly. They just could not. Because if they would pick some parts and they'd like to have a place for this part to go in and get fitted, the part won't fit because of quality variation. And these variations were to the extent for this stage of business, whenever they were doing that, there were 300 to 400 defective parts per million parts purchased by Chrysler. How would they improve it? They went after their first tier suppliers. Remember the supply chain. The remember has many tiers of suppliers. You got your factory, then you got tier 1 supplier, then you got tier 2 supplier, then you got tier 3 suppliers, and so on and so forth. Ultimately, of course, you got the raw material supplier. Chrysler made sure that the factory, whatever it got fed by tier 1 supplier, they used high level of quality control. And then anyone that followed, that were like feeders, tier 2 supplier, tier 3 supplier, tier 4 supplier, they also had to come up to the level of this tier 1 supplier. So the strategy that they used was, they forced all the downstream suppliers, these are at higher tier numbers, tier 2, tier 3, tier 4. Those guys, they had to be at the same level as the tier 1 supplier. Now, the tier 1 supplier, his quality level was most visible to Chrysler. But the other guys, they were kind of hidden. But Chrysler made sure that the other guys, they also improved. They got to the level of this tier 1 supplier, so that, in fact, the pains of the tier 1 supplier got minimized. The result was they were able to get down to the level of getting supplies from tier 1 supplier that was at 100 parts per million, pushed all the way back. So every supplier, regardless of what tier he belonged to, he came up to the level of 100 parts per million. That of course is not very high, but starting from where they started, which is like 400 parts per million, getting from there to 100, that was like a 4-fold improvement in quality. And that of course this march was on. As you know, Six Sigma never really stops, because even if you reach 4 Sigma, 5 Sigma, there's always that 6 Sigma to shoot for, and even beyond it. Because even at the 6 Sigma level, you've got a few parts, 3 or 4 parts per million that are defective. So you could even shoot for better quality level. If you do not do these things, there is going to be huge buffers all the way in the system, and there will be inventories, and the result is going to be raw material inventory, working process inventory, finished good inventories. These are all going to be large. You may also require capacity buffers, because your rate of production must once in a while get bumped up. So you must have some capacity buffers as well. And also perhaps you'd like to get more lead time, because you get that time to fix your problems. So lead times can also get expanded. All of these things would add to inventory and it would add to non-productive use of money. That's something that you'd like to be able to avoid. In fact, if you look at a supply chain, here I've got a supply chain and there are some inventories which are required by the nature of the process to achieve some sort of synchronization, and I put them in blue. These blue points, these blue dollars, those are kind of required, but look at all the red dollars. These are unwanted buffers. These really should not be there in the system, but they are there because of problems, quality problems. In fact, it turns out that whenever you've got inventory, a lot of problems hide behind these inventories. For example, if your inventory is just about, what normally it is, the problems that are visible to you are machine breakdowns. So if a machine breaks down in a shop, you can spot it because there is pile up of inventory there, and that's because there is a lot of inventory on the floor anyhow. A machine breakdown becomes quite easily visible. But what about if there are workload imbalances? That's not quite visible when you've got large inventories, because the inventories, they end up absorbing a lot of these issues, these problems. What about out of spec material? Again, if you've got large inventories of products which have been screened and so on, again, products being out of spec either at the finished stage, or intermediate stage, or the raw material stage, those also stay hidden. Quality problems, they also stay hidden if you've got large inventories. Material shortages, notoriously they stay hidden, and I personally experienced this thing when I was in a plant, when I was operating a plant. I had the same issue there. I had large inventories, so many times material supply problems, they're not visible to me. And if one or two workers are absent again, and if that's a problem, if that's a recurring problem, that also gets hidden if you've got large inventories. You can live off the inventory and that problem will not be there. So in fact, it turns out when you've got large amount of inventories, only 5% of the total problems are visible to you. Couple of ways we could improve quality, which is, the first is of course reduction of variability. That's like one way. The other is go after waste reduction. These two ways, these two also are the targets of Six Sigma projects. You try to reduce variability. That's like something first you'd like to do. You'd like to reduce the fluctuations. You'd like to reduce the fluctuation in quality, for example. You'd like to make sure your production is perfect and it's consistent and it's all tight within a narrow band. That's what we'd like to be able to do, like we do in Six Sigma production. The other thing is also waste reduction. If you do not have waste, again you are improving the system. There is clearly a link between quality and productivity, because if you're lacking quality, then you're producing a lot of stuff which you cannot sell in the marketplace. So that link is also pretty clear. In fact, it turns out that if you've got poor quality, that can be quantified in the form of cost of poor quality. You'll have high inspection and testing costs. You'll have a lot of repair and rework. You'll have a lot of scrap. You'll have a lot of warranty service, and these probably are going to reduce your process yield for sure. And of course, then you've got a lot of hidden costs also. These are preventable costs, but unfortunately they are there if I do not take the preventive steps. And these can get quantified in the form of cost of poor quality. I should caution you that the traditional accounting systems, except for perhaps reporting scrap and perhaps warranty through the CRM systems, they do not really report a lot of these things and they stay hidden from management. Then of course, we've got what we call hidden costs, and look at them appearing one after the other in this slide there. I've got certain costs that are visible, which are like scrap, rework and warranty costs. Those are visible. Those are the tip of the iceberg, literally. Then there are these other costs which are highly cost intensive, but they are their conversion inefficiency, inadequate use of raw materials and resources, excessive use of materials, for example, cost of redesign, reinspection and so on. That's also an additional cost. Cost of resolving customer problems because there is a problem with the product that I sold him. Lost customers, goodwill, these are also costs, corporate costs. And of course, high inventory. These stay hidden when you've got high inventory. That's just the tip of the iceberg. Here's an example of a company, how they avoided quality failure. They implemented with their suppliers, they implemented what we call real-time SPC. They did not have real-time SPC before. SPC is statistical process control, which is your control charts, use of the control charts. This was one company Quickie Tools, they went after their suppliers and they forced them to use SPC. And the result was just amazing. Yes, it was painful. But what it did was it reduced the risk of receiving bad products. And that would lead to higher level of customer satisfaction, more business, and they could actually share some of that extra profit, some of the extra money that they made with their suppliers that they could do. And this is how they ended up incentivizing. In fact, they provided incentives for their suppliers to produce superior quality products and parts. And there are, of course, quality tools, various quality tools you could use. TQM is one that we've already mentioned, 7 tools. We also discussed them in one of the earlier lectures. Statistical process control, that's also a way to try to improve quality, and this can also help in supply chain management. And of course, the DMAIC procedure. Let me give you an illustration. You might actually think that getting to the Six Sigma level is really for the birds. Most of us do not really need Six Sigma. But if you really look at the best-in-class people, they really have Six Sigma type of performance. So if you're stuck down here somewhere with 2 or 3 Sigma level, that's where your percent products are. That's not going to be a very good situation. What you really should be able to do is move to the upper end. Move to the upper end when you've got very few defects, and your defects are the level of parts per million. Let me move to an example where I use this DMAIC framework. I define customers and their priorities. I measure the problems, and I do that by looking at the process and by measuring its performance. I analyze the data, and I try to look at the cause of the defects, and then I try to improve using various causes that might be causing those problems there. Then of course I try to control, try to maintain quality. And here's an example of a supply chain situation. The Nissan Motor Company found in their full supply chain, which is like producing the car and giving it to a customer and then waiting for his experience, for example, they found that the logos in the back of the car, those kept falling off. And this was a big problem. They did some brainstorming about it. This was a supply chain issue because it really hurt the ultimate customer. And they were not having a good experience with this. So what they said was, let's try to approach this using a very powerful method, which is of course design of experiments. What they did was, they first identified through a process of brainstorming, they identified the various factors that could have caused this, and they set them up at 2 levels. Then of course they used this design matrix. This is the DOE design matrix. This particular matrix happens to have 8 different trials, and the process settings are given by what I have described to you earlier in one of the earlier exercises, and they measured the response as the gluing strength of the logo sticking to the car body there. So there was a glue applied to this, and then the logo was pressed on this, and they measured after the drying time, they measured the strength of a particular setting, a particular combination of area, the type of glue used, the thickness of the foam used, and the logo, thickness of the logo. After doing that, then of course, they computed what we call the factor effects. And the result is just amazing. They did some plotting, and these are the plottings of the factor effects. And you can see very well that factors such as type of glue, thickness of foam styrene, and the thickness of the logo did not seem to matter at all when it came to gluing strength, and it seemed to be most affected by what we call adhesion area. As area was enlarged, the logo stayed on for a longer period of time, and that was one of the things they were looking for, one of the things they were really looking for. QS 9000, of course, is the system, that is the certification system that must be utilized now by all automotive parts suppliers. Many of them are using DOE. Many of them, they are optimizing their processes. They're using design of experiments to try to make sure they get to the optimum answer in the quickest time possible. That is something those guys are doing. This is something that's not very easy, but once you have the orientation of DMAIC, which is like define, measure, analyze, improve, and put in control. Once you apply this framework for your approach, and you're doing this on the foundation of TQM and so on and so forth, if you're doing all of those things together, you're going to be one of the winners. And this has been the cutting edge. This has been really the hallmark of companies like Toyotas, for example. The Toyotas and the Hondas and so on. They are the ones who are utilizing these techniques, and they have started from literally from the ashes. They've reached the tops tops in market share and customer satisfaction in the world, in the automotive world. So the picture is pretty clear here, and the message also is very clear. If you stay this way, you're bound to succeed. You're bound to outcompete others who are also going to be in the same marketplace, looking for the same bucks from the hands of the customer. That's something that has happened in the world of supply chain also. And as you saw, we told you the story starting from the raw material, the intermediate process, and so on and so forth. As you squeeze out the fat that is there, which is like if you squeeze out inventories, the problems will become visible. And that's really the secret. Once the problems are visible, you'll go after them. You'll be using techniques such as DMAC, such as TQM, such as SPC, such as 7 tools, and so on. And definitely it's going to lead to better profits. We'll continue with our series in the next lecture onwards. Thank you very much. Thank you.